Second test only covers it covers quadratic equations and piecewise functions. So the stuff we did last week and then the stuff we're going to do today. Part of the stuff we're going to do today. So you guys already know about piecewise functions, you just don't know that you know about them.
Really?
Yes. Has anyone ever looked at their power bill before?
What?
Yeah.
The power bill?
Yes.
How do they charge you for power?
By kilowatt hour?
Kilowatt hours.
By kilowatt
plus
hour.
the base charge.
Plus the service charge, plus the taxes. And what about the kilowatt hour rate? Is it all the same rate?
No, it changes per month.
It changes.
It's tiered.
It's tiered rate, yes. A piecewise function is like a tiered function. It has different functions based on what your inputs are. Okay? So it has different equations that you would use to calculate based on what your input is. So if your kilowatt hours are a certain amount, you might use one equation to calculate. If your kilowatt hours are something else, you might use a different equation. So it's kind of like a tiered system. Like the power company, like a cell phone plan, if you have, you get a certain number of minutes, and then if you go over that, it charges you 5 cents a minute, something like that. Like riding in a taxi where they have like a base rate that they charge you, and then they charge you so much else per tenth of a mile. Okay? So you guys know about this, you just don't know that you know. Okay? So first of all, let's figure out what these look like. So the way what this might look like you might say x squared plus 2 if x is less than or equal to 4. Or negative 2x plus 5 if x is greater than 4. Okay? So first thing you need to do is figure out which category your x value falls into. So if they tell me an x value, I need to say, well, is it less than or equal to 4, or is it greater than 4?
Oh, okay.
Okay? I just need to figure that out first.
What?
And then once I figure that out, I use the equation that goes with that category to calculate my y value. So what if I ask you for f of 2? Which equation would I use?
Greater than 4.
No, you use less than or equal to 4.
Okay, 2 is less than or equal to 4, right? So 2 would fall into the first category. So I would use the first equation to calculate. So I'm going to take that first equation and plug in 2 for x. So I have 2 squared plus 2. Okay, so 2 squared is 4, plus 2 is 6. So my answer there would be 6. Okay, what about f of 5? We want to use the first equation or the second equation? The second one, because 5 is greater than 4. It would fall into that second category. Okay, so I plug in 5 into the second equation, negative 2 times 5 plus 5. Okay, that's negative 10 plus 5, which is negative 5. Okay, what about if my x value is actually 4?
Greater than or equal to 4.
Okay? You want to use where the equal to is. The equal to is with the first equation. So equal to 4, I would use the first equation.
Is there always going to be an equal to 4? Or is
There'll
it?
always be an equal to one place or another.
Okay.
Okay, they always have to include that number somewhere. Okay, now the equal to could have been on the second equation. That would just mean you would include 4 with the second equation. Okay, so when I plug in the first equation, 4 squared plus 2 is 18. Okay, that's all there is to it. The only way it gets a little funny
Free graphing calculator.
Good, probably. Let's try that.
And how would they have us graph?
Well, you can't really do it on the calculator. What you have to do is you kind of have to graph both equations and then kind of erase what you don't want. Okay? So these are called piecewise functions because your graph is going to have different pieces. So what I would do is I would graph both equations, x squared plus 2 and negative 2x plus 5.
So would you only use that?
Okay, what I want to do is I want to say my switch happens at 4. X equals 4 is where I'm going to switch from one equation to the other. So what I want to do is I kind of want to think of like a vertical boundary at x equals 4. I'm going to draw a vertical line here.
Could you zoom that out?
Zoom it out. What do you mean?
I mean, so that it's more obvious that the parabola can see it more.
Okay.
Sorry.
Like this?
Yeah.
Okay, so x equals 4 then would be
Sorry, Courtney.
You made it harder.
right here.
Yeah.
Okay. Now, I want the parabola, which is x squared plus 2. I want that for x is less than or equal to 4. So which side of that vertical line would that be on?
The left.
The left, right? The left is x is less than or equal to 4. So I want the parabola on the left, which means I'd want to ignore the part on the right. Okay? Now which side do I want the line on? I want the line, which is negative 2x plus 5. I want that for x is greater than 4. X is greater than 4 would be over here for the higher x values.
Are you pasting that to your notes this round?
Yeah.
Okay, awesome.
Okay? So my line, I want to erase
Now, how do you know? Well, actually, I guess you would look at the function what is greater than or equal to 4 and what is less than.
Yeah, well, just think. These x values are bigger than 4.
Yeah.
So this side is bigger than 4. These are less than 4. Okay? So less than is always going to be on the left. Greater than is always going to be on the right of that vertical boundary. Does that make sense?
Mm-hmm.
So what kind of question is this going to help us solve?
A graphing question. Now the graphs are multiple choice.
Oh, okay, gotcha.
Okay? Because they can't figure out how to make you graph this. So they can. Yeah. Stuff that's multiple choice means they haven't figured this out yet. So, you just need to figure out the general idea of the graph. You know, not actually how to plot points or anything. Now there's one more feature of my graph that I need to look at, which is how do I tell myself that x equals 4 is on the parabola and not the line? Since the x equals 4 was with the first equation. Okay, so if I sketch this, just a rough sketch would look like this. So this is 4. Okay? What I want to do is I want to put a circle on the end of each line to tell myself where 4 is included. Okay? Now if 4 is included on one graph, you want to put a closed circle on that graph. And if it's not included,
Put an open circle.
you want to put an open circle. I want to put a closed circle on my parabola because that equation had x equals 4. equation, you want to end that line with a closed circle. And anytime you just have less than or greater than, you want an open circle. Okay, so that's what my graph would look like if I tried to graph it. If they asked me to choose one, that's the one I would choose. Okay? Now usually the way that they vary the choices is they put the circles in different places, you know, or they'll switch them, they'll have like the line on this side, the parabola on this side. So it's usually like different variations of the same graph.
So it's always going to be a line and a parabola.
No. That's just because of the equations I made up.
But sometimes it'll be two parabolas.
It could be two lines, it could be two parabolas, it could be all different stuff. Depending on what your equations are.
Is there ever 3 equations?
There could be 3 equations. Okay? What's my one on the homework?
Where did the word piecewise come from?
I think it's the graphs are in pieces, I guess. But other than that, I really don't know.
Number 10.
Well,
What do you make 12 from? Number 10's got 3.
So it's
Number
4.
4 has 3. Who's number 4?
Interesting.
Okay. So first of all, figure out what your x value is. So what's my x value for the first part?
-8.
Number of your x value is the number in parentheses, so -8 here. Okay. Now which category does -8 fall into?
Less than -4.
So my first category is x less than -4. My second category, you want to read that as x is between -4 and 1. My third category is x is greater than or equal to 1. Okay? So -8 would be less than -4. That falls into the first category. So I'm going to use my first equation. Plug -8 into my first equation. Okay, and then just calculate that. That's 40 minus 12, which is 28. Okay. Now I'm not gonna type in my answers because then I don't want to erase what I'm writing. You guys can try yours and put in your answer.
There's a second answer to it.
Okay. The next one it's going to ask me is -3. Okay. So what category would -3 fall into?
-3 is actually, it's still below -4.
Okay.
No, it's
Between -4
yeah.
and 1, right? Between -4 and 1, so it would fall into the second category. Now what do I do if I don't have an x to plug into in my equation?
It equals 1.
My second equation is just equal to 1. That means no matter what your x value is, answer is always 1.
What did you say when that was the case?
So see how my second equation is just h of x equals 1? In the middle there? So there's no x to plug into. That just means your answer is 1 no matter what. Okay, so my equation it's just a constant equation. Like your answer would be 1 no matter what.
That's weird.
So yours
Gotcha,
is
mine's 3.
Yours is 3. So h of whatever
Is
always 3.
Gotcha.
And yours would be 0. What about h of positive 1?
X plus 6.
Okay. Now my middle category is just strictly less than 1. My last one is greater than or equal to 1. So for 1, I need to actually use the last category, because that's where equal to 1 is included. Okay, so that would be 1 plus 6, which is 7. last one is h of 4. Well, 4 is definitely greater than 1, so I would still use that last equation. And I get 10 on plus 6. Okay? So basically you just choose which category your x's fall into, and then you just plug into that equation. Give you guys a second to get number 4 if you haven't yet. Let's look at number 6 next. Did you guys get number 4? Look at number 6. Number 6, I want to graph my equations, negative 4x and positive 4x. Let's go back to our graphing calculator. Okay. Now, what they told me here is, what did they tell me? I don't remember. Negative 4x for x is greater than or equal to 0, and positive 4x for x less than 0. Let me write that on my graph here. Greater than or equal to 0, and less than 0. Okay.
So would you use the bottom two?
I would use the bottom 2. Yes.
Yay.
Because negative 4x is my red line. So which side of 0 do I want my red line to be on? The right side or the left side? X is greater than or equal to 0 is the right side. So I want my red line, which is negative 4x, to be on the right side of 0. Okay? I want my red line to be on the right side. That means I'm going to erase the left side. Okay? Now positive 4x, which is the green line, I want my green line to be for x is less than 0. X is less than 0 is on the left of 0. So over here I want my green line. Okay? Now remember guys, you cannot have them overlapping vertically. They cannot fail the vertical line test. Okay? So I know if I have my red line right here, I can't have the green line up here too, because that would fail the vertical line test. You're only going to have one line in each part of your graph. Okay? My graph would look like that. Okay? Now if they actually meet at the same place, like these meet up at 0, you don't need to worry about open circles and closed circles. Okay? If they meet at the same point, then they just form a point together. Okay? So this one would not have any open or closed circles. What about what?
7.
Number 7? Okay.
Has the
Look at number 7.
Starting to really like these.
Okay? Negative x plus 5. You said said you like these?
I'm starting to really like
Anybody
it.
else like these?
No.
Can I get a, you guys look fun?
I do not.
Oh, they're not too bad. This is a short homework. Okay, so negative x plus 5 and x plus 7, let's graph those. Okay, let me zoom this back in actually. Okay, so negative x plus 5, it told me x is greater than or equal to 0. This is just like what we just did. X is greater than or equal to 0 and x is less than 0. Okay, so remember x is 0 is the y-axis. So I'm going to have one line on the right side of the y-axis, and I'm going to have one line on the left side of the y-axis. I just need to figure out which one is which. Okay, so x is greater than or equal to 0. Would that be the right side or the left side?
Right.
The right side is greater than or equal to 0. Okay, so my red line, which is y1, negative x plus 5, my red line should be on the right side. That means my green line would have to be on the left. So let's erase the red line over there. So the red line's only on the right. And the green line would have to be on the left. Okay? Now I just need to figure out what my open circle and my closed circle go. You're always going to have one open, one closed.
The greater than or equal to is on the and is in the red line equation.
The greater than or equal to is in the red line equation, so the red line should have a closed circle because it has the equal to.
Yeah.
So my closed circle should be on the red line. Okay, and the green line has no equal to.
It's an open circle.
It's an open circle. Okay, now I just have to pick a graph that matches that.
Oh gosh. Gooey.
Okay. Now they're all pretty similar, so you have to be careful on this one.
There is no circles.
No.
They're positioned.
There's no circles. These are screenshots from the calculator. The TI calculators will actually graph piecewise functions. They just don't do circles.
What it is you have to look at the ticks and the view setting.
Well, what I'm also you're making your jump at +1. This one looks like it's jumping at -1. See how it's jumping on the left side of the axis? This one looks like that's jumping at +1. That's jumping at +1. That's jumping at +1. Now +3 for x is greater than or equal to 1. +3 should be.
Should be above the first two.
It should be above the x-axis, right?
Yeah.
So +3 should be on top, on the right. -3 should be on the left. What's the only one it could be here?
D.
It can only be D. See, I've got +3 on the right, -3 on the left for D. B and C have -3 on the right.
Look at 8. That one's kind of interesting.
A is jumping at -1. That's the problem.
Oh, I see.
+1. B has -3 on the right instead of on the left.
That one's actually -3.
I think B and C are the same graph.
No, B is -4.
One of mine looks like that too.
Oh, B is at -4. Yeah, it's still wrong though. D is right. Now, probably if you view an example on this, it'll actually walk you through. tell you an example how to enter this into the TI calculators if you want it to graph a piecewise function. What it misses here is they don't tell you that you would enter this into y equals. So where they have the 3 parentheses x plus x greater than or equal to 2, you would enter that into y equals.
Oh, cool.
And tell it to graph, and it'll graph the piecewise function. Okay, so those can